there's quite a lot of you coming to listen me rambling on like the past mistakes of all of us. So hi. Why the talk? Why the topic? I recently, like last couple of years, I see this kind of direction of us making mobile games into really an MMORPGs, which are just like a products that we develop for 8, 9, 10 years, expecting revenue. So we are working with very old code bases. Then we have games in early access on Steam for 10 years, right? Some are like very successful, Rimward, and like some are super buggy, 7 more days to die, like so. Like we are here, and we have this issue of depth. Crouching on our minds. So who am I? That's me. Little bit younger. I'm mostly Unity dev for 11 years. Started with C++, but that was a long way ago. What I like doing most in my job is actually thinking about the architecture, how our projects are constructed, and talking with the devs on how they see the issues that we're facing and how can we improve. I was a CTO at Boombeat, didn't like it much, so I'm now back to being hands-on the project, which I enjoy much more. So let's actually try to define what is the depth that we're actually going to talk about, because in this article by Chelsea Troy, she says stop saying technical depth, but mostly what she means is not defining the depth in terms of bad code or just bad code, because the technical depth is more than just like our code structures and architecture and stuff. That's the processes and the people and the team structure that led to this moment. So I'm gonna try to define this with you. I didn't use ChatGPT yet, but maybe next year. This is a Wikipedia quote on technical debt, which says that the debt is a cost of an additional rework made by us choosing the easy solution first instead of the better one. But I don't really, this doesn't really resonate with me because sometimes the easy limiting solutions are just what not only the project needs, but also what the business needs. Well, at the end of the day, we are making games. We need to deliver the products. So we are making a lot of decisions, and they need to be mindful of the entire structure that we're building. So I like this quote by Paul McMahon, that all code is technical debt. Some just has a higher interest rate, and when you think about it, like really think about, like, Paul has a lot of good ideas here, because like if you look at some easy stuff, like a pop-up that just wants you to invite users to Facebook. We made it once, it's shitty, but it works. And I never need to go back to it again, right? But like, if I have a critical system inside, like the entire system for displaying the entire UI, and that's like inherited from a game that's 15 years old, that's something that we are paying higher interest rate on in the code. The thing is that we work in the past. If you think about it, like our code from most of our code that we're writing today refers to the code that we wrote tomorrow, refers to the code that we wrote a month ago, a year ago, or someone that the CEO of the company, current CEO of the company, does not know, but was working there 11 years ago, and you still need to interface with it. But like in the reality, if we are looking just at the code, we are kind of disregarding all the other components that took us there, right? So for the sake of this talk, I offered this definition for you, that technical debt is property of a project that degrades the ability to develop it further. So we look at the code and we look at the processes that led us there. So the first question to ask, how did we find ourselves? Like, the technical debt, if we're starting to think about, like, talk about technical debt in our project, it wasn't there yesterday, right? Or was it? Like, someone left the door in and then the technical debt just snuck into the project, right? So have you ever wondered when in your project the debt thing started? Like, and this is kind of where the analogy to the monetary debt kind of falls apart, right? Because when you are going to a bank, to get yourself into a debt, right? You take a loan with the expectation that you need to pay it back. But this is a conscious decision that you're making. And more often than not, in development, you are not making this decision of, oh, okay, I'm gonna need to pay it back sometimes, and I know the monetary value of how much it's gonna take me. So there comes in a moment in our project, right, when we start feeling that weird tingling sensation that something is just not right. The game works, we may be earning money, but something in the code, right? Something is just not right. And this is kind of the point. Like, we are starting to think about the technical debt only only when the consequences appear. So these are like I hope it's visible back there, the kind of questions you can ask yourself to check, like a unit test, whether or not your project has a technical debt, right? Like, maybe the features take more time to develop. Maybe you have developers churning because they don't want to work anymore on this project. They don't want to work with this critical system written by some guy that doesn't work with us anymore. Maybe developers say, oh, I need to refactor this, I need to refactor that. This needs a rewrite, right? And every time you go and sit down and plan the next sprint, you need a rewrite, and something is just not right. And I kind of don't want to touch the legacy code vibe here because the legacy code is the code that I didn't write. But on the other hand, it's a code that makes money, right? And we are scared to change it. Maybe we don't have the test coverage to see if we can iterate over it. Maybe just the code is in C or in Java or JavaScript, and we really don't want to like look at it anymore, right? Maybe it just makes you sad. So I don't want to talk about legacy. Like, we can have another talk about legacy code and how to deal with it. But like, legacy code is a part of technical debt. But for legacy code, we are kind of not responsible. We kind of got it, okay, and we need to interface with it. We might improve upon it. We might improve upon the interfaces, but for the short term, we're kind of not able to do this. So let's try to find some reasons. Like, how did we get here? And let's talk about business first, because first there's money, right? We basically made an entire industry. I'm talking we as a mobile developer because I worked in mobile in most of my life. We made hyper casuals. Those were made to be made in 3 weeks. Then they had to show as many ads as possible in the shortest time possible, and that was their only purpose, right? But then, hey, how did if we got in-app purchase here, or throw some cards to collect, and then the hyper casual starts to earn money, and we're seeing the profits, so we want to invest, and now we want to introduce a new gameplay mode, and the architecture doesn't support it. Like, I'm playing ads through the controller that steers the player because my entire game is just this one piece of code. So yeah, some money is for sure one of the things. The other one is time, and I'm not gonna talk about the crunch issues here in Poland, especially, because crunch is just one of the way, right? We are pressured by time to deliver stuff faster, to deliver stuff today, and sometimes it is also self-imposed sense of urgency, like. I can make it. Like I can make this feature in 2 days. Oh, I wouldn't make it in 2 days. Like, come on, have you seen me? Like, and this self-imposed sense of urgency makes us into making suboptimal decisions about how the entire system that we are building fits into the general whole. There is also like issues with development scheduling. We can have fantastic speed of development. Like we can churn out 700 story points a week, but our agility is low. Like now the business changed its priorities, and now we need to turn. But we were developing with a straight line ahead, and something that we want to build now is not necessarily compatible with what we have built. There is this great talk by Kevin Henney on agility is not equal speed from multiple conferences. I remember NDC Oslo mostly, so go check it out. I'm gonna have this in notes for you later. And the last business reason for me is my favorite, which is the fork. And this is what businesses want to reuse code, right? We want just to take our old Fallout game, make a new Fallout game, right? And with Fallout New Vegas, it kind of worked for the long run. For the short run, like Fallout New Vegas flopped, right? Because it was developed in 18 months, just as fork of Fallout 3. And in mobile, it's just more of the same. It's just like, oh, we have this game successful, now just change the gameplay and we're good, right? Right? And as a person who was developing basically an ability to get a modular system together, like to make a make a game modular. I can talk about this all day, but when you think about it from people's perspective, if you have a successful game and now you want to fork it and make another successful game, give it to another team. Now this new team is being responsible for the mistakes and the wrongdoings or good doings, but it's not our code, right? The legacy. And being blamed that they can't deliver features at the speed that the first team, that the original team, was able to churn out new features. So this is very disheartening for new developers that are joining the new project. And you can end up in a situation when you fork the games so many times that when you plop a preprocessor define on top of the coin, on top of a game, it kind of changes it to motorbike racing from your RPG, and I know this from for a fact. So let's talk about now. Stop with the business, because like business gives us money, right? We like money, so let's focus on actual things that we developers can do, both on processes and code side of things that we do that generate technical debt. That's my point. So, quick question: how many of you has a formal architect in the team that you're working on? There's like 4 hands. Great for you. I'm so happy for you. Yeah. So whenever we start a new project, we kind of don't often think about the holistic picture of how our game should be structured in the long run, because it's impossible to, right? We don't have all the requirements. We work agile, so we want to iterate on the features. So often the product, the business, they come to you, oh, I want this game, can you make a quick prototype, right? Go with the flow, see what happens. And how many games have started from a prototype and then the shipped product was basically just a iteration on this prototype? There was a great talk by Kasper Kwiatkowski from Vile Monarch years ago, I think 9 or 8, on throwing your prototypes to trash. And I really like this idea because when you iterate on single concepts, you could work on them in isolation and then just throw that prototype in the trash and re-implement everything into the final project. But sometimes, either because of the time pressure, the external time pressure, or the internal time pressure from the self-imposed, right, kind of makes us, I kind of have this code running here, I don't really want to rewrite it. I know I have much more context now, but should I? It's gonna take like 2 days. So we carry over all that prototypeness of it into a final project, and I for one think that we really can't say that we have no architecture because we have bad architecture, right? We even have a term for it in architecture. It's called a big ball of mud. You can hear about it a lot when you're hearing about monoliths and microservices in the backend. So yeah, that's the thing. Like, we didn't think about how new features gonna fit into this entire whole. Maybe we weren't given time, or we just rushed into it. But what is architecture? I really like this piece of trivia from the book from Niels Ford, because architecture is not only the code, right? It's how things inside the code communicate, how the entire systems which build your game, because sometimes it's not just the application. It's gonna be maybe some server that's authoritative for your game. Maybe there's an entire backend microservices hell just an API gateway away, right? There is a documentation, there is the processes and the people. There is the thing called the Conway's Law that says that any organization that designs a system will produce a design whose structure is a copy of the organization communication structure. And this means that not really and Conway's doesn't mean like the hierarchy of people with CEOs and leads and managers. He means how people communicate. If I'm like directly communicate with developer as a product, if I directly communicate with developer, not with the team lead, not with the architects, and I'm just skipping the entire thing, it's gonna be reflected in the code. It's gonna be reflected in the system that's we built. So how we build the code kind of represents the nature of how our team operates. The next big thing is no guidelines. Developers are very opinionated people. I, for one, am one. And we have no guidelines. We often just hire new people and say, oh, look, this is the game manager. You put all the code here. This is the player controller. And this is the settings. Here we also start game. But don't look at this, right? So what I'm seeing is that many people just now hire the new devs, especially when you hire senior devs. They are the most opinionated people ever, and they want to name stuff differently that you have in your project, right? They want to build a new classes. They want to like separate an entire thing, and our role as the leads is to say, yes, I understand you. Okay, like I see where you're going. But this is not how we want to build for consistency. And if we don't have the guidelines to support it, right? Then like, what do we have? Like if all the code that we have in our code base isn't just an abstract thing without any structure to it, what do we have to back it up for ourselves? Do you know what this picture is? In World War II, there was an island in the Pacific when the Japanese and later the Allies had their military bases, and and they were like receiving all the cargo for those military bases, food and etc., through airdrops. Um, so. And some of the cargo was distributed with the natives, the Melanesians that were living on the island. And then the war ended, spoiler alert, and the Allies left the island. But with no cargo dropping by, those native people have started to construct structures that represent planes, the watchout towers, tanks and stuff, in hope for the cargo to drop. Because they didn't understand the underlying purpose. The biggest war of the world was unraveling in front of their eyes, but they didn't have the context to understand what's going on. And this is and we have the same thing in technology. It's called cargo code programming, which, as Wikipedia now, again, didn't use ChatGPT, says that it's a ritual inclusion of code or structures that serve no real purpose. And I think we've all seen this with the huge jump to ECS. Like, so Wuga went into said, oh, hey, there's Entidust. Now we made this ECS now. And now every studio wants ECS, even if they didn't need ECS in the first place. Right, without the understanding of what's going to take to implement and what's going to take to actually maintain. And it's not just like game dev, right? Recently, just 2 weeks ago, Amazon, the company, they have the Prime streaming service. They released a paper that they say how we kind of reduced our costs of streaming by migrating from microservices into a monolith application. And the entire public part of internet just went on, oh, Amazon, they sell microservices, they sell you AWS, and now they say that microservices are bad. Let's just now move to microservices. And they didn't mean that. They mean that they understood the underlying costs that they were generating, and they chose to move from microservices approach to the monolith to optimize for costs. Right? Uber 2012 said, oh, we are migrating from MySQL to PostgreSQL. So the entire IT went like, woo, PostgreSQL, let's go. 2 years later, Uber says, we're migrating from PostgreSQL to MySQL. And everyone like, oh, PostgreSQL is bad. This is the underlying thing is that there is no one size fits it all. There are no silver bullets in development and architecture. So whenever we are just going into the internet and reading another article of like how this thing gonna make your project 700 millions faster, and without consideration of the entire whole, this is what we are doing. We are building the structures, hoping for an airdrop. Next one is this big. So code review. We can actually split code review into two things. One is the PRs, right? Except okay, and the one is the actual code review. So if you have PRs, I hope you do. I'm happy for you, like because this is a first step. Like if your development is based on PRs, this is great. But often when talking with developers, I don't see them having an actual code review sessions when they sit down and say, "Oh, look, this is our guidelines. Like, let's take this class and see how does it fit in the entire whole." I don't care who wrote this class because this is not the point. Like, just sit down, look at what's its purpose, and see how can we improve to align with our standards. Because like across 100 PRs, there might be changes that just either accidentally slipped in or we just couldn't see it in PR because we see in PR one line, right? We didn't see that it has added a 400th line into the method, right? So code review is no code review. is one of the factors that we are getting. The other one is poor code quality, and there is a lot to it. There was this meme when I wrote this code. Me and God knew only me and God knew what's going on, and now only God knows. For the lack of documentation and the lack of comments. When I hear another developer telling me, "Oh, my code is self-documenting. This is great. I'm just like super," and who's judging this? Who says that your code is readable? Who says that your code is self-documenting? You? Or you who was writing that code 2 years ago? Or this new dev that just joined the team and that looks at the game controller manager singleton something, right? And it finds out that it makes in-app purchases. Because why not, right? And like, of course, this is another topic that we can like talk for an hour, but this kind of builds up on the lack of guidelines. If we have a lack of guidelines, then we invite the poor code quality into our code base, and then we have the voodoo, right? Because we don't know how to do this stuff, so we go to Stack Overflow, we go to ChatGPT now. Like I go around the office sometimes and just see how many developers have ChatGPT open, and like 3 weeks ago, I literally had to argue with ChatGPT on something like that was very reasonable, but kinda like it made a fundamental mistake. And this is the future that we are going on, because like most of the devs won't have an idea what's going on, and most of developers now, I think, start programming from engine tutorials or from like video tutorials on YouTube or TikTok now or ChatGPT, right? Not from programming. So we are starting to not be game programmers, we are starting to be game developers, we are starting to be engine operators. And building for something that's going to last as a project for 7 years, it's important to understand, okay, this is my team. I'm not saying that like whether or not you started on learning Unity on TikTok, that's fine. I'm happy for you. I'm happy for you to be here. It's for us to understand that if we have those members of the team, we need to start to guide them and see and show them the path of like, okay, I understand that you can make this in 2 lines of code, but those 2 lines of code are gonna like make our architecture collapse. So let's have this reverse perspective for a moment and look for the strategies that we employ when we see that we have technical debt and now we want to make things better, right? So what we do, we slap some patterns onto it. And in Hitchhiker's Guide to Galaxy, there was this quote that says it is a mistake to think you can solve any major problems just with potatoes, right? We can easily adapt it to using patterns. Because I often see developers just saying, oh, I have this problem in my code, let's just slap MVC, MVP, MVVM, ECS, and everything on top of it, just to add another random meaningless keyword in our code with no real purpose. Like, there is this term, which is called architecture erosion, right? By adding stuff without looking into a ready product, by adding stuff without looking into the greater whole, you're kind of eroding the underlying architecture, however good or bad it was, but without finding a place for it in the perspective of a greater whole, you are making the thing worse. And there's like so many developers think that this book is just a checklist that I need to implement every pattern from it. Like, if you have ever read this, there's a lot of critique about this, which says that this book defines 9 or 8 things that are just missing from C++ in 1994. So so this is not a guideline for it. This is not a checklist that we need to implement. Like our game gonna be fine without a single factory. It depends on the scope, right? Jimmy Bogart, the guy behind the doing the domain-driven design, says that when I build my code, I don't want to think about it in terms of patterns. I'm gonna only use a pattern when the code that I wrote kind of speaks to me that the solution would be best implemented by a pattern. But if we go reverse, and this is what we usually do, I'm here to blame too. Like this is like an absolution for me. When we go from a general perspective, we tend to say, oh, okay, I have this configuration manager. That's going to be singleton, right? I have the enemies, so I need a factory, right? I have bullets, so I need an object pool. But I only have 2 bullets entire game. So why did I build, right? And this is kind of where we are getting. Focus is our key to success. Like if we are building the code that we might need, but not necessarily right now, we are taking the responsibility of actually maintaining it. Right now when the game doesn't compile, because we added an extra API endpoint, because some developer for sure gonna use it in 2 sprints from now we are responsible to maintain it. And we are putting in extra effort to put it there. If you will need this code, do it when you will actually need it. Why waste time now when you have features to deliver if you just want to like expose 3 extra endpoints? Are they tested? Are they like gonna be QA'd? Because nothing in the code calls it. And then they're gonna live there for 3 years. A developer comes in and says, string search. Someone actually calls it through reflection. And so like, what? And the last thing I think I want to talk about is complexity. We love complexity. Like I for one, like if I can have any one of you seen the FizzBuzz Enterprise Edition on GitHub? This is a fantastic piece. This should hang in museum. Like there's just like 10 factories there. There's no factory, but like it's in Java. So just a content warning for you. If you don't really like Java, you might not want to go there. There is something intricately beautiful in naming your class all the beautiful names. Like we love managers and controllers and interfaces and services and systems. But even if though the underlying system is much more simpler, we kind of feel this particular sense of achievement when we are making something elegantly complex. And there's this quote from Neil Ford, the architecture book from before, that developers are drawn to complexity like moths to a flame, often with the same consequences. And the decision to make some complex code didn't consider to maintain it later, right? We just kind of felt that like it feels right now. But we didn't produce documentation with it, like keep up, and then we need to keep it up with our updated quality standards. And sometimes the complexity just happens because we're lazy, right? Like if I've seen hundreds of projects, we're just gonna have like three singleton base classes in them because like we didn't want to write a singleton each time, and then there's 3 teams actually working on this, so each of them made their own singleton base. Did we really need to make this complexity here? And now the game starts with 700,000 logs of just saying, oh, this singleton is not yet in the scene. This singleton. Why do we do it? The bigger something is, the harder it is to get it rid of. So if we can minimize the complexity, that's going to be it. I think I need to make another talk on the deleting code, because this has been like my true hobby for the last couple of years. I just love deleting code. So, like we know the bad stuff now, right? Okay, so how can we make it better? This is the cheapest way. Just build guidelines for your team. truly just, if you can sit down with your developers and have a true-hearted discussion of, hey, okay, let's do the system this way, let's name our functions this way, let's name our things this way, we use this, we never use this, why, etc., etc. If we can have this discussion, then everyone feels on board. And trust me, like if you have a team and the team has the guidelines, once they see a code that doesn't fit to the guidelines, they will want to automatically correct it because it just feels natural. The code doesn't feel great. The other thing is static code analysis. Not associated with all the logos here. This is the tools that I used and I checked. If you don't know, there's of course the Sonar Cube, which is the most big enterprise thing you can have. So if you're a big company and you have big rules and big architects, probably Sonar Cube is the best. Cordana, that's a new product from JetBrains, which actually supports Unity quite decently from the 2023 release, and supports all the scene references and shader issues and custom rosin analyzers, which are very simple to write. So if you told your developers, I never want you to call toString, that's your rosin analyzer, you plug it into Cordana and you work. CodeScene is very interesting if you have not used it, because it analyzes your depth through going through Git history and sees, okay, this file had 700 changes in the past 2 months, and many developers collaborated on it. So if you want to prioritize the technical depth, working on technical depth, this might be the tool that's useful for you because it's going to show like where actually developers are making contribution, where the merge conflicts happen, and what we might want to focus on. This is something that we as leads need to mostly communicate to our managers. Prioritizing early and thinking about the depth while we are iterating on the project is really the crucial part of improvement. Allocating some improvements every sprint is very vital. The gradual improvement is mostly the prevention of decay. Not saying that like, okay, now we need to tackle this huge refactor, it's going to take a month. But if we can find small things that we can improve on, that's going to prevent our project from totally collapsing in the future. Challenge yourself. If you wrote a system, and we are very opinionated people, just try to think that the guy or girl that you didn't really like wrote the system. Like, try to approach it from a different perspective, right? Just sit down and critique it, and find you will be able, if you train hard enough on this, you will be able to identify most of the issues that like you had in the past because you have all the context, right? But they don't fit now, and this is gonna make you a better developer over time and over time and over time. If you're working alone, just post a question on Stack Overflow. They're gonna tell you what's wrong in like 3 seconds. Take small steps. Like, there's no point in diving into huge reworks if you haven't done your homework. If your team structure is bad, if your communication is bad, if you don't have guidelines, like, there is no point in actually making a huge rewrite. Because what's going to see you? At the end of the day, we are making game. We are making a product that we want to deliver. We want to deliver the next feature, right? So there is no point in rushing. It just needs to come naturally with the flow of the features that we are gonna bring. Don't over-engineer. When I started my game development journey, I know I still have 5 minutes. I loved complexity. I love like just building like input system from Unity. Like, I can make it just so much better. But for what? And what's the purpose of us actually trying to build this huge machine that's gonna just take a tap from a game? Focus on what's needed now and how it fits into the greater whole. Thank you. These are you can reach me out on Discord. I don't really use Twitter. I'm gonna have the slides on my GitHub, and this is LinkedIn if you're interested. Of like just chatting. If you have any questions,
Yes.
Then
Thank
there's
you,
a mic.
Szymon. Do you have any questions? Yes? No? No. Okay. So before... Yes? Please?
So you said that the architecture is a kind of fundament and it has to be hard to change. And are you a fan of making your own architecture solutions in-house, or are you using some third-party tools? And why? And do you think that maintaining the architecture as some kind of plugin, even if you write it on your own, is a better solution because you can change it that easy?
Yeah. The architecture is actually, if you think about the architecture as just one component that you can take into the project and then take it out and have it on another project, that's not really the key thing here, because the architecture is actually how all those systems communicate with each other. You might have a different architecture for your gameplay. Let's say we have an ECS, right, inside gameplay, but then you go out from a gameplay in an MMORPG mobile game, and then your system, your monetization system, your live ops, they don't run on ECS, right? Because why would you? So there is this misleading conception of thinking that architectural patterns are the same as architectural styles. And for architectural styles, I really, I had this book referenced. I really recommend the book on architectural concepts for developers, because this kind of gonna switch your perspective. That architecture is not really a module that you can have. It is how the entire structure is kind of fluctuating. So every time you build a project, you kind of build it in-house. You don't really use any other tools.
But there are some tools that can impose some solutions onto you and make you write your code in a certain way.
Oh yeah, most definitely. Like you might, for example, be forced to write modules or something, right? And this is just a decision of the company that you are in and of the project that you're in. So,
what's your experience in using third-party plugins or solutions that impose this style of coding?
Well, I'm from Unity. My most life is Unity, and my general hot take for Unity is that every plugin written in Unity is kind of thinking that they're the only plugin inside the Unity project, and they want to actually just rewrite your project for their online liking. So if we don't really need to take the advantage of that third-party plugin, let's just not use it, because it's actually gonna make a voodoo magic happen in our project.
I'm not talking about plugin that brings some functionality into the project, but plugins like, for example, Zenject that forces you to create a certain architecture.
Zenject, like dependency injection, is just basically like a 5-cent idea for a $25 idea for a 5-cent concept, right? Because you're just injecting, have a fancy way to put your parameters into a constructor. This is not an architecture. The architecture is actually how your services between your assemblies gonna communicate. How you're gonna name your public methods. How are you reading data? Where the data is stored? What's the flow of communication between them? Zenject has nothing to do with it, because it's just a tool that you're using, right? Like Unity. Unity enforces some of the architectural decisions, but your architecture is not really this.
Okay, yeah, I get it.
Okay, thank you. Do you have any questions?